Hey everyone, welcome to video 2 of AirDev's Leetcode series. Today we will be going over the second problem in Leetcode called Add Two Numbers. This problem and this video assumes you have knowledge about linked lists where each node has a value and a next node in the list. If you'd like to know more about linked lists, let us know and we can make a video about it. Great, so let's start by reading the problem. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum on a linked list. You may assume the two numbers do not contain any leading zeros except for the number 0 itself. So let's look at the example. We have list 1 is 2, 4, 3, and list 2 is 5, 6, 7. So since this is stored in reverse order, it's actually 342 plus 465. So let's try to do this math without a linked list. We start in the ones place with 2 plus 5 equals 7. So we write down 7. Next we have 4 plus 6 equals 10. So let's write 0 and carry over the 1. Now we have that 1 that we carried over plus 3 plus 4. Adding these all together, it's 8. Therefore, 342 plus 465 is equal to 807. Notice how we started at the ones place of each number to add digits before continuing working our way through to the tens and hundreds place. If we look at our linked list, this is really convenient because our list starts at the end of the number, so we can start our addition right from there. Each time we add, it's the number from L1 plus the number from L2 plus maybe a carryover. So the idea here is to translate our arithmetic logic into code, which can probably be done through a while loop. So our while loop will state that while we have a value in list 1 or list 2 to add, or if we have a carryover value, we'll continue to add our number value. This takes care of the case where if list 1 is only a single digit and list 2 is a triple digit, or you add two numbers that go into a new numbers place, like 50 plus 50, which ends in a carryover of 1. But wait, how are we going to add these numbers and store it? Well, we need to create a new linked list since this is what the problem is asking for. We can start by creating a variable called current and give it a dummy head of 0. This is essentially a starting point so that our list is not empty and we can add values to it. You can write any number here instead of 0. It will not be used. Next, let's create another variable called head. Head will be equal to current because we want to keep track of the very beginning of this linked list, and we can't do that with current since it will be updated in our while loop. We put return head.next at the end because we want to return the real start of the list, not the dummy head value of 0. Since our while loop condition is while L1 or L2, which means that either list contains an element, we need to check which one exists, as it could be both. If either one exists, then we will just set them to the next item in the list. This way we are not stuck in an infinite while loop and can continue our addition. So, how do we add two numbers? Well, we need variables to keep track of the numbers in L1 and L2. So let's set variables v1 and v2 to be equal to our position in the list. If we reach the end of the list in either one, we'll initialize it to 0 so we don't have any null values or errors. Remember, this can happen because our while loop states if either L1 or L2 are not at the end of the list. And we will initialize a third variable called num, which is just the addition we did at the beginning of the video. It's the value of L1 plus the value of L2 plus any carryover from previous additions. To get the carryover, you can check if the number is greater than 9, or you can do this neat Python trick called floor division, which is represented by 2 backslashes, and we'll use 10 as the denominator. In other languages, it's most likely from a math library, and you can use math.floor. Floor division rounds down the result of the division of two numbers to the nearest whole number. So for example, if we had 12 divided by 10, its results would be 1.2, but if we round down, that is just 1. If we had 9 divided by 10, its results would be 0.9, but rounding down is 0. We use 10 as our denominator because we want to see if the result is greater than 9 or not. So if our addition results in a carryover, the floor division would always be 1, and if it didn't, the floor division would be 0. So now you're probably thinking, okay, well, where will we store our number? Well, in our linked list, of course. We need to create a new node in the list where its value is our number. But wait, what if our number is greater than 9 since we did addition? We can't store a 2-digit number as a node in the list, so we need to use modulus here, represented by the percentage sign. Modulus is an arithmetic operation that gives the remainder when the first number is divided by the second number. One example here is 10 mod 10. Well, when we divide 10 by 10, we get 1.0, so our remainder is 0. But wait, what if we have 12 mod 10? Well, 12 divided by 10, we get 1.2, so 2 is our remainder. By keeping 10 as the second number, we ensure our remainder will always be 1 digit and the correct value. Okay, but remember at the end, we need to update our current to be the next value, otherwise we'll always override it. So now let's try to run this. Well, we had some picky Python here with the spacing, so let's indent it and run again. And now we need to format the comments from earlier. So let's try to run this yet again. Thanks for watching, and I hope you found this video helpful. Let me know in the comments if there's anything you'd like or didn't like and what you want to see in the future.